Hello, welcome back to my Tech Fun. I have a 3D printer review for this video, and this is KP3S 3.0, and this box is sent to me by the Kingroon in exchange for a review. A few specifications about this printer. The print volume is 180 millimeters in X, Y, and Z direction. It has the direct drive extruder with a gear ratio of 3:1. It has a removable magnetic print surface, and it has linear rails in X and Y direction. On Z, unfortunately, still use those V-slot wheels. And beside this box, I got two filaments. One is PLA and the other is PETG. And of course, since this is direct drive extruder, I will test it with some TPU too. I don't have information about print temperature, but probably it has some Teflon line hot end, so it is not recommended to go above 240 degrees Celsius. But this is very cheap 3D printer. Maybe its main competitor would be Ender 2 Pro. But anyway, let's see what's in the box and see how it prints. The packaging is good. Everything is nicely protected during the shipping. So it is quite pre-assembled printer. This is the base and this is the Z-axis with the X gantry, which has to be mounted. Power supply, and it looks like it is separated. The cable, this is the Z-axis screw. Knob, probably for the extruder. Some sample filaments, and I already mentioned my opinion always if I see this kind of sample filaments without a spool. The spool holder, user manual, and some spare parts. With some tools on the cable. My user manual is in German, but it is very easy to assemble it, and it has very nice and clear pictures. I'm pre-installing the side bolts and the T-nuts. Later it will be easier to assemble it. And then I'm moving the printer to the edge of the desk, and I am placing two bolts from the bottom. It's easier to assemble it this way. And after this I can tighten all these bolts. I'm preparing the lead screw, and always I like to check is it straight. That's very important. And this one looks okay. And I'm using this coupler to connect it with the shaft from the stepper motor. And I'm tightening these screws around the trapezoidal nut. Printer is assembled in maybe 10 or 15 minutes, and its footprint would be very small, but the problem is that we have this power supply separately. It would be much smaller footprint if I could place it in vertical position, but there is a cable which comes out from the bottom, so maybe on some legs we can use it in this position. I saw some solution on the internet when they place it under the printer, but the problem is that it is not easy to access to this switch. So I think this part needs a little bit more development. And I'm very curious, how can I place this sample filament on this spool holder? I saw some solutions on the internet where we can print some kind of spool holder and we can mount it here on the top of this Z-alloy extrusion. And if you place somehow the power supply below the printer, its footprint would be really small. Just for comparison, side by side, this is Ender 2 Pro. Because of the price and the structure, I think Ender 2 Pro is the biggest competitor to this printer, well, maybe Prusa Mini too, but that's 2 times expensive printer. But here we have linear rails and a direct drive extruder compared to this one, and bigger print volume. And just to compare the size, approximately 15 millimeters bigger. About this print sheet, I think the material will stick good to it, but we will see that soon. But I'm afraid that this is a little bit too soft. This may be the problem if you print something from ABS or any material which likes to warp. Even if it sticks good to the print surface, there is a danger that it will lift. But good news is that we can buy separately a print sheet, and I recommend to use something on the steel. For example, this is for Ender 2 Pro. This PI sheet is placed on the steel sheet, and it's much harder to lift it, so it will hold better the position if it has some warping filament on it. With PLA and PETG, I'm sure that there will be no this kind of problems. And my curiosity, I want to see what is inside. Just removing 8 screws and the plate is down. Well, on the main board it has Kingroon KP3S 1.3. And from here we can access to the y-axis timing belt, but it is already assembled and the tension is not adjustable. I'm not very familiar with this mainboard. I can see 4 stepper motor drivers. They are cooled with this fan on this plate, and unfortunately high current wires, they are just thin there. I cannot see ferrules on them. Interesting, there is a space for another stepper motor driver. Theoretically this is ready for some kind of upgrade. It's a pity that we don't have a space for another Z lead screw and a stepper motor. Before powering on, one more time check the voltage on your power supply. Is it set correctly for your country? And also it is good to check the tension on this V-slot wheel. We have only one setting nut, and you can use this open-end wrench to set the necessary tension. In my case, everything was preset correctly, including the timing belts, because usually I suggest to check the tension on timing belt, but here we don't have possibility to adjust. Probably this would be longer than if we had some kind of tensioner here, but in factory it's set correctly and it's good as it is now. I will start the leveling process, but first I want to compress these springs. They're almost fully compressed, so I'm reducing the chance that the nozzle will hit the bed, because this is a little bit softer, and if it is hot, the nozzle might damage the print surface. Leveling. It is so-called assisted bed leveling, so it will move automatically to the desired spot, and then we can rotate the knob until we get perfect friction between the paper and the nozzle. So it is now homing the X, Y, and Z. I'm not sure is it visible on camera too, but I have here at least 5 or 6 millimeters between the nozzle and the print surface. That's too much. I cannot compensate that with these knobs here. So I have to lower this screw, and the Z limit switch will be pressed a little bit lower. Let's try again, homing. Okay, this distance is now approximately 1 millimeter, and this I can compensate now with these knobs. For the first leveling, I like to use 2 paper sheets. With this, the Z offset is a little bit bigger, and I'm avoiding that the nozzle will be too close to the print surface and the object will stick too good to the bed. Moving the Z axis higher, but the bed is leveled. Smaller beds are always easier to level. The leveling actually means making it parallel with the moving path of the nozzle. Not really natural position for the end of the filament. It may break by time. For the first print, I would suggest to print something from the SD card, because this G-code is prepared by the manufacturer, and if there is any problem, I know that this is not case by the slicer. Food clip fast, okay. So let's see what can we do during the printing. Here we have the information about the nozzle temperature, bed temperature, and the fan, but we cannot adjust them. Let's see what's in option. We can pause or stop the print, adjust the temperature, maybe change the filament. Let's see what's under more. Fan speed and manual. Not much, so I'm missing here setting the Z offset, because fine adjustment I can do during the printing. These adjustments here. But good news is that this surface is less sensitive to human errors. A little bit closer or farther, the filament will stick good to it, unlike the glass where we have to set that Z offset distance very precisely. I already mentioned earlier not to natural path of the filament into direct drive extruder. It would be much better if this filament would be somewhere here and the path would be much smoother. And less space would be used on a desk. Printing is finished a few seconds ago. It would be good if it would be finished in this position. And now let's try to remove the object from the bed. Perfect. And now I am adding the printer to the Ultimate Care Cura, Kingroon KP3S. And I'm not changing anything here. And the first object will be the calibration cube, and I will slice it with the default settings. The screen is a little bit small, but the menu is good organized and we always have finger-sized buttons. And the first layer is okay, which is good because I cannot set the Z offset. And this is the timeless of approximately 30 minutes. The surface quality is very nice. Let's check quickly the dimensions. X, Y, and Z. Quite accurate cube. And of course, let's print a Benchy too. Interesting click sound we can hear during the retraction. Maybe that's the backlash of the gears, I'm not sure. The Benchy looks much bigger on smaller print surface. And partly thanks to this shiny filament, this Benchy looks great. Absolutely no stringing, nice work of the direct drive extruder, great overhang. Only these seams are visible, but that's always the case. And in the meantime I also measured the noise from exactly half meters. 46.2 decibels average. This is very quiet printer and I will add this value to my summary table on my website. It's a little bit hard to find the correct file because only first 10 characters are visible. Now I can see the full name. With my next printing I want to use the maximum volume of this printer, well at least in Z-axis. The slicer didn't allow me 180 mm, so it is 179. It's a trash can designed by Brian from BV3D. And it will be printed in a spiral or vase mode, and sometimes we can see some additional problems with some printers because the power loss function may interrupt this smooth moving of the pad, but we will see. Everything is okay with this spiral vase mode printing. There are no breaks in the printing and no spots. Printing at 80%. The printing is on 161 millimeters. An interesting behavior I noticed. So it's stuck here first and now in this arm. So this kind of things you have to pay attention if you are printing on the top Z-axis. And also keep in mind that if you design some kind of spool holder, it will be in the way of this cable if it is somewhere here. If I support it like this, maybe some plate here, in that case it will not stuck in this arm. Temporary solution until it finished last 10 millimeters. But now it doesn't stick here. Last 3 millimeters, and instead of a spool holder I will create some kind of holder for the arm, and it will solve the problem. And exactly at this moment the printing is finished, and I don't understand, so nobody prints on the maximum Z offset, and this is at maximum position. I need one more small but important test print. Pin support challenge. This means everything is okay with the part cooling and the extrusion is very good and constant, and of course I have decent bed adhesion. And it's finished. I think the biggest challenge now is to take it off from the print surface without breaking it. And it's perfect from the bottom to the top, only I noticed the sphere is not completely perfect because the part cooling is only from the one side. And it's time to change the filament, and I want to print something from PETG. It will be a holder on the top of the Z-alloy extrusion. It will solve two problems. One, it will be easier to carry this printer and I will not grab this lead screw on the back side. And the second, you saw, it will guide this cable if I print something on top of the Z coordinates. From higher position it always has nicer filament path. And this was printed overnight with a very minimal stringing. Okay, I was afraid that it will stick too good, but it's perfect. And I know I have a skeptic viewer, so I printed another one. One is for testing and the other is for installing. Actually, the reason is that this is a little bit too small for my fingers and this is much more comfortable. But this will be for testing anyway. Okay, not too scientific approach, but I think this can hold my weight, which is 1.1 kilonewton, and that's much more than the weight of this printer. Any questions? And what I like with PETG, it is not so strong like PLA, but it doesn't break so suddenly. But this is in perfect shape. It's time for installing. I'm tapping M5 threads in existing holes. And just in case, I'm using some bigger washers under the screw. And the handle is ready. It feels great, and also I will not damage the lead screw by grabbing it like here. And also it is prepared now to printing on those higher Z coordinates. PETG can absorb moisture from the air, so I always like to keep it in some resealable bag. And my last printing for this video will be from TPU90, because this is direct extruder, so I want to test it with the flexible filament. The printing started correctly, it looks okay, the first layer, and I have only 40 degrees on the bed because I'm afraid that it will stick too good to this sheet. We will see that at the end, in approximately 1 hour. Now let's see how easy it is to remove the TPU from this bed surface. Oh, great! The surface quality outside is great. Inside I can see some stringing, but we always have the problem with the TPU and the stringing. So this is not bad, and of course not the best object for this testing, but I really need this. It's a doorstop, let's test it. And actually I will have one more printing from PLA, because I want to measure the power consumption. You can see the average consumption, probably when the heating is on, and now it turns off. Heating of the bed mostly. This is in watts. And this will be the total in kilowatt hours. And exactly a few seconds ago, after 1 hour and 16 minutes, it switched to 0.1 kilowatt hours. Object is printed in 2 hours and 23 minutes. I can see the scale stays 0.1 kilowatt hours. Properly it would jump to 0.2 in 10 minutes, but this is one of the lowest power consumptions to the printer I ever tested. And my final thoughts about this 3D printer. Well, it was very pleasant surprise. So small printer, very cheap, but actually the print quality is great. And it is very easy to assemble it. And if you can fit into this print volume, 180 millimeters cubic, and 240 degrees Celsius temperature on the nozzle is enough for you, this is great printer. For those who run a print farm, I will tell you one example. Imagine you have to print 2 pieces 100 millimeters calibration cube, for example. Well, for price of NS3 S1, you can buy 2 of these. On S1 you can print 1 at a time, but as I mentioned, here you can buy 2 of these and you can print them parallelly. So it is good extension to those print farms, because if those objects can print on, fit on smaller surface, you can print on these small printers too. And don't forget, their power consumption is smaller compared to the bigger printers, of course, because the biggest consumer is actually heating of the bed. Of course, there are a few things that I didn't like about this printer, and there are some space for improvement. For example, theoretically, the footprint of this printer is very small, but don't forget, if we place the spool holder to the side and also the power supply separately, in that case, its footprint is bigger than, I don't know, NS3, for example. Of course, there are solutions. You can place the spool holder somewhere here, power supply below the printer, and in that case, yes, really that footprint would be much reduced, but it would be good if this would be prepared in the factory by the manufacturer. Also, don't like that this timing belt is not adjustable. Okay that it is preset in the factory, but the tension, if I don't know, in a year or two I want to set it, or I replace the timing belt, it is very hard to place the correct tension on it, on X and on Y equally. Definitely, I would recommend two very quick upgrades. One is to remove this soft print sheet with some flexible, which is on steel sheet, and especially if you want to print ABS or something like that, which would like to warp. And also, I would like to replace these springs. They are a little bit weak, and if you put some stronger springs, it will hold the position of the bed much longer. And one last thing which I didn't like actually is this power supply. I'm not sure what type is it. It has quite ugly noise from the fan, but if it is outside, basically they could provide some passive power supply without fan. It would be even quieter. It is quiet machine, but with that it would be even quieter. And I'm not sure, I'm not expert, but I think it's not the best quality, because I can hear those transition sparks when I use this switch. So I think a little bit better quality power supply would be better, and as I mentioned, it would be better if it is passive. Of course, I know it is challenging to fit into this price, which is far below $200. Anyway, I highly recommend this small printer if those limitations I mentioned earlier are okay for you. If you have some additional experience, write me 4 lines in the comment section. Thank you for watching and happy printing.